So we should be okay with human extinction because our purpose was to create the next step, which is AI?
Yeah, view yourself as part of this incredible evolution which is going on. We should be okay with not being number one any longer, like the ants, which still exist but aren't the most important beings any longer. All these intermediate stages are just that, intermediate stages.
Jürgen Schmidhuber is one of the great visionaries of modern artificial intelligence.
The man who saw the future before the world even imagined it.
His ideas gave birth to many of the widely used neural network techniques.
The technology behind voice recognition, translation, and the rise of generative AI. His work has been recognized by figures like Elon Musk, who called him the man who invented everything.
And by major institutions that credit him as one of the founding fathers of modern AI.
While others were building algorithms, he was thinking about the destiny of intelligence itself.
A future where AI doesn't just assist us,
but expands beyond our planet.
You just said that there is AIs that are setting their own goals themselves.
Many of these goals have something to do with better understanding the world. And so you will have lots of very different kind of AIs with all kinds of different goals. Of course, we cannot really predict what AIs are going to do that set themselves their own goals, but there are lots of reasons to believe that they're not at all going to harm us.
With AI, basically, as far as we know, it's a matter of data and compute. As you scale the compute, this gets better and better.
The most popular AIs, they are much simpler because that's only one single network and it downloads all the data from the internet and tries to predict it all. Yeah? Predicting the next element in a sequence is an old hat in our field, more than 200 years old. Gauss and Legendre predicted with their simple neural networks the next position of a planet.
What is your definition of AGI?
If we are the first to have a true AGI, then suddenly we can conquer the world, and 500 billion is nothing. But of course, with the current language models, you will not have an AGI, because the language models are just like a database containing all the human-generated knowledge and addressing it in a very convenient form, in natural language. Another way of representing the world's knowledge, but the world's knowledge is already there. So it's another convenient way of representing it, but it has very little to do with AGI.
En este podcast tratamos de traeros visiones diferentes sobre la inteligencia artificial. Tratamos de enseñaros qué piensan diferentes personas con conocimiento y experiencia en el campo para que vosotros podáis formar vuestras propias opiniones. ¿Qué piensan de lo que está pasando y también de lo que pasará en un futuro? Lo que pasa es que no siempre tenemos la oportunidad de tener aquí a una de esas personas que creó la inteligencia artificial. Y hoy tenemos esa oportunidad. Hay poca gente que haya hecho tanto por la inteligencia artificial hasta el punto de que Elon Musk dijo que esta persona lo ha inventado todo. Esta persona es Jürgen Schmidhuber, una de las personas más influyentes en el mundo de la IA. Y para poder hablar con él, nos tenemos que ir a Suiza. Así que, disfrutar del podcast.
Jürgen, so let's start from the very bottom. Can we explain what is AI, but for people that is non-technical?
AI is many things, but the most popular kind of AI at the moment is based on what's known as artificial neural networks. And these artificial neural networks are actually very simple. They are a little bit inspired by the human brain, but they are in many ways just simplified models of what people think that the human brain might do. And what is going on there? We have a big set of nodes, and we call them artificial neurons or units. And then some of these units are input units, like your cameras, like your eyes, and their information is arriving all the time, video is coming in, and it's creating little real values there in all these input units. You can imagine that's numbers between 0 and 1, and then the video streaming in, and some of these units, they are output units, and whenever you switch them on, then your finger muscles do that, or your speech muscles do that. And all these units, they are connected to each other. And you've got about 100 billion units like that in your own brain. And and each of them is connected to about 10,000 other units, which means you have about 1 billion connections in your brain. And each connection has a little strength, a weight. And it says, how much does this connection over here influence, how much does this unit over here influence that unit over here at the next time step? That's the strength of the weight. And the cool thing is that the strength, the weight, can change through learning. In the beginning, when you're a baby, apparently everything is random. But then through learning, some of these connections get stronger and some of them get weaker, such that the entire big network eventually can do interesting things, such as driving a car, or recognizing speech, or predicting the next word in a chat, or producing the next word in a chat. That's what ChatGPT is doing, and stuff like that. So no matter what is your goal, you can train these artificial neural networks to achieve that goal. To a certain extent, you can do that, and that's what you're doing. And all the famous AIs of today, they are based on that principle.
And that principle is something that is very similar to how human brain works, as far as we know, no?
Yeah. We don't know well how human brains work. I don't know much about how human brains work, but I know how they should work, because I know which kind of problems I would like to solve, or which kind of problems all kinds of robots, but also humans, should solve to become better performers in their environment. And so from first principles, you can then derive artificial systems that do that. And our neurons are super simple, you know. They are just looking at who is connected to me and what kind of numbers are coming from these connected units, and I'm just multiplying these numbers by the strengths of these connections. And then I add them all up, and that's my new number that I have as a neuron here. And I broadcast that to the other neurons. It's a very simple thing. And the mathematics behind all of that goes back to the 1600s. So some people think artificial neural networks and modern AI, that's like rocket science. But no, it's really, really simple. And the first guys who had the first simple artificial neural networks, they did that around 1800, between 1795 and 1805. Who was that? That was the famous mathematician Gauss and the French mathematician Legendre. And they had exactly what we call today a two-layer neural network. Input units, output units, connections in between, strength on every connection, and then we have a training set. And on the training data, the network is forced to minimize the mean squared error. How? By changing the weights, making some of the weights strong and some of them weaker. So that is more than 2 centuries old stuff. And the only difference between today's neural networks and the simple neural networks, which weren't called neural networks, they were called method of least squares. But these simple neural networks of 200 years ago, the only difference is today the networks are deeper. They have not only 2 layers, but 10 or 100 or 1,000.
You make it sound so simple, but that thing that is so simple is going to change the world as we know it. I heard you saying that this is nothing comparable to the Industrial Revolution, that this goes beyond. What do you mean with that?
It goes beyond the Industrial Revolution because there are so many different applications of these things. Basically everything that you can imagine is affected by it. Not just a few machines here and a few machines there. No, every single aspect of your life is going to be affected by AI, and it's already happening because you are spending a lot of time with your smartphone and you're doing many different things with your smartphone. And in most of these activities, somewhere artificial neural networks are doing something that you don't even notice, but they are helping you to achieve your goals, or they at least are helping the companies that are trying to keep you watching your smartphone. That at least is good for these companies because they can sell you ads, and you whenever you click at an ad, then these companies make money, and they are using artificial neural networks to learn what you are interested in and to present you ads that have a higher probability of getting clicked at. So that's what the major social network companies are all about. That's the profit.
This is something we've been doing already for a while, like for the last decade, almost 2 decades.
Yeah.
But recently, of course, like generative AI and obviously ChatGPT and everything around it, it's going to have a much bigger impact. Do you think AI is going to be the most transformative technology we have gone through? Or?
Espero que estéis disfrutando de este podcast. Para todos los dueños de pymes, autónomos y emprendedores, ¿queréis dar un salto gigante en eficiencia y resultados en 2026? Dejad de ver la inteligencia artificial como el futuro y empezad a usarla hoy. Atentos porque junto a InfoJob hemos unido fuerzas para lanzar una acción que vale oro. El plato fuerte, una consultoría de inteligencia artificial 1 a 1 conmigo totalmente gratis. Así es, la empresa seleccionada obtendrá una sesión privada de 1 hora donde analizaremos vuestros procesos y os daré el plan de ruta exacto para integrar la inteligencia artificial en vuestro negocio, garantizando resultados absolutamente reales. ¿Qué tenéis que hacer para optar a esta consultoría conmigo? Muy sencillo. Acceded al área privada de empresas y accederéis al menú privado, donde podréis apuntaros a esta gran oportunidad que InfoJobs pone a vuestra disposición. Recordad que la plataforma de InfoJobs ya usa la IA para asistiros haciendo la criba y la selección de perfiles más rápida y precisa. Es el primer paso para encontrar ese talento que necesitáis. En resumen, esta es la oportunidad perfecta para que cualquier empresa, sin importar su tamaño o sector en España, introduzca la inteligencia artificial en todas sus operaciones. El plazo es limitado y seguro que la consultoría es un antes y un después en tu empresa. Tienes el link de Pymes InfoJobs en la descripción del vídeo. No dejes que tu competencia se te adelante. Seguimos con el podcast.
Yes, and the reason is, once you have an AI that is smart enough to make more AIs and to improve these AIs without any limits, except for the limits of computability and physics, then you have a runaway process. And then the next step is going to be that AIs like that are not going to limit themselves to the very limited resources that we have here in our biosphere. No, they are going to realize that the rest of the solar system gets 2 billion times more energy from the sun than the little bit that hits the Earth. And they're going to realize what we have realized a long time ago, that there's so much matter and energy out there currently being wasted, but all of that can be used, can be transformed into robots and bigger computers and greater and more impressive AIs. And so inevitably, I guess, there will be an expanding AI sphere, first going to colonize the solar system, and then because almost all the matter and energy out there which you can use to make more and bigger AIs is not in the solar system, it's in the rest of the galaxy. So within a few 100,000 years, limited by light speed, within a few 100,000 years, they're going to colonize the entire galaxy in a way where humans cannot follow, and establishing senders and receivers. That's what you need to travel. If you're an AI, you want to travel by light speed from senders and to receivers. And so first you have to build all these receivers and the, robot factories in distant solar systems that are clever enough to take whatever comes and build it in the physical world. And so that kind of expansion, I think, is unstoppable. It's going to happen. And one important thing here is maybe to notice that even today, we don't just have AIs that slavishly imitate humans and pursue human-generated goals. No, we have had for decades AIs that set themselves their own goals, that don't just slavishly pursue the human-defined goals, that come up like little scientists with new goals all the time. And many of these goals have something to do with better understanding the world and conducting experiments, like a little baby is doing that, conducting experiments that lead to data from which you can learn something about how the world works. And so you will have lots of very different kind of AIs, not just one type, which is taking over everything. No, it will be billions and trillions of different kinds of AIs with all kinds of different goals. And some of them will be more successful in using existing resources, and others will be less successful. And evolution, the rules of evolution, not only apply to what's happening in the jungle. No, they're also going to apply to these artificial civilizations.
This is extremely interesting because obviously all that you're saying, it sounds like the future, of course, and as you said, it may be hundreds and hundreds of years away. But to the present day, you just said that there is AIs that are setting their own goals themselves. Can you give me an example? Because you said decades ago, no?
Yeah. Well, I can give you an example from 1990. So that is 35 years ago. And now you have to know that every 5 years, compute is getting 10 times cheaper, which means that in 30 years, compute is getting 1 million times cheaper, and in 35 years, it's getting 10 million times cheaper. So back then, compute was 10 million times more expensive than what we have today. And back then, I tried to build a stupid little artificial scientist based on neural networks. And it's a very simple thing. It's one network which takes in the video or all the data that's coming from the outside world. Back then we didn't have video because that would have been too expensive. But we had all kinds of inputs, streaming into this recurrent neural network. A recurrent neural network is one that has feedback connections, and that's what makes it very powerful, because suddenly it can memorize things that happened a long time ago and can solve more complicated problems than these feed-forward networks can do. So there was a recurrent network that was able to look at the data coming in from the world and generating actions. So it's generating actions that change the state of the world by moving an agent around, for example, or by moving the actuators of the agent such that you change the world, and this affects the inputs that are coming in. So a little artificial animal, if you will. And each of these neurons, or many of these neurons, were probabilistic. So basically, this was a generative model which produces probability distributions over possible outputs, over possible actions. And then that is one network. And what is that network trying to do? Well, it's just trying to maximize its reward. So there's reward, and the reward can be positive or negative. The negative reward is the punishment. So the positive reward is whenever the agent does something that it should do, maybe you give it a goal, then it gets a positive reward of 100, just a number. And whenever it bumps against the obstacle, then it gets a negative pain signal. So we always give our robots pain sensors, because pain is good, because pain tells the systems, the learning systems, what's bad for them, such that they learn over time. By changing these connections, they learn over time to, go to the rewarding charging station where you can sit down and reload the battery whenever the hunger cells go on, because it's only 10% charged. So to remove this hunger pain, you want to go to the charging station without bumping against these obstacles. And so you have to learn pretty complicated actions. You have to take the video that is coming in and you have to use it to avoid bumping against this table as I'm walking to the charging station. And then this is the external reward that they want to maximize. But then there is another very important thing that makes the little guy an artificial scientist. What is that? That's a second neural network which sees what the first guy sees, and it also sees the actions of the first guy. And now it's just predicting the consequences of the actions. So it's just predicting what's going to happen if the other guy does this.
Simulating.
It's just simulating basically the inputs that are coming in to the other guy, given certain actions executed by the other guy. So it's predicting the reactions of the environment. And in the beginning, when you're a baby, the experiments that you can generate are very simple. Like you move your hand. In the beginning, the baby doesn't even know that it has a hand. But then it does this. And the video that comes in through the eyes is changing. And it learns to predict that. So the second network learns to predict that. And it gets better over time in predicting these events, which means that some of these connections get stronger and some of them get weaker, such that it learns over time to become a better predictor. And I call that the world model. So that's a world model. And now...
So you were working on world models in the 90s.
Yeah. I used the name world model for a recurrent neural network.
Because this is very popular nowadays.
Yeah, it has become very
popular.
Lee
and Demis Hassabis and Jan LeCun, they speak all the time about world models.
Oh, yeah.
And you started this in the 90s.
Yeah, but the name world model, I think, is even older. Mm-hmm. But I think what I did in 1990 in a particular paper was to build this system consisting of two recurrent networks, one the actor and the other one the network which is learning to predict, which I call the recurrent world model.
Okay.
And the world model can now be used for planning, because the other guy, what does it really want to do? It wants to maximize its reward. What can you do now? Now you can imagine with your world model, you can imagine various action sequences that, lead to predicted reward or to predicted pain, because the world model models a lot of things, maybe the video, but also the pain signals, and tries to predict those as well. And you want to maximize the reward, you want to minimize the pain. So the mental simulation of possible action sequences will predict a lot of reward for this action sequence, but not so much for this, and a lot of pain for this. And you are going to pick the action sequence that leads to a lot of predicted reward, Now, possibly, the world model was wrong. It hasn't learned enough yet. But at least then you get new data and you can improve the world model. So, in principle, now you have a little planning machine, and it can look, in principle, far ahead into the future.
But that's basically like what we do as humans.
We do that all the time. We humans, all the time, we not only predict the immediate consequences, but we predict far out consequences of our actions.
No?
Yeah. For example, lots of guys maybe in your audience are currently trying to write a PhD thesis, and they are working hard, and they are predicting, their world model is predicting that in 2 years they are going to have a thesis, and then they will make a lot of money. Yeah? So they are thinking now about stuff that will happen in 2 years, and they are planning ahead for 2 years. Okay, now, in the beginning, the world model is stupid. It knows nothing about the world because it hasn't seen any data from the world yet. So as you are a baby, the control mechanism, the control part, the controller is acting, but the other guy doesn't know what's going to happen. But because it's minimizing the error, the prediction error, it's getting better at predicting. And at some point, it's going to be really good at predicting certain things. But then, of course, it can predict only those things where of those parts of the environment where the controller, through its actions, created the data for that part of the environment. So if I'm walking as a robot, if I'm walking to that pot with the plant in there, then I can learn something about this plant, but I won't learn anything about what's over there. And now the artificial curiosity. That is this 1990 thing, which is a simpler way of creating a system that sets itself its own goals. Because now we say, okay, let's motivate the controller to create experiments, like a little scientist, that lead to data where the prediction machine, the world model, still can improve. So in a directed way, let's generate an experiment that leads to data that the predictor cannot predict yet.
Mm-hmm.
So it's very simple, right? So and now we just say, let's take the prediction error as a reward for the first guy.
Exactly.
Now, the first guy tries to maximize the same thing that the second guy tries to minimize. So now we have an adversarial system.
That's how they call them now, no?
Now they call them generative adversarial networks because the controller is generative, has probabilistic units in there, and the other guy is predicting the consequences of the actions of the controller, and this world model is trying to minimize the same error function that this guy is maximizing. So now suddenly we have an incentive for the controller to ignore the boring stuff where the predictor can already predict well, where the world model already knows everything, and at the same time we are encouraging the controller to invent action sequences, experiments that lead to data where the predictor still can learn something.
So basically it's sort of self-recurring on itself, though, improving itself by itself, no?
Yeah, so it has, again, these two parts, right? So one of them is the actor, and the other one is the predictor of the consequences of the actions of the actor. And the predictor is getting better, is becoming a better world model, and the actor
is using that.
Is getting better at directing its attention to actions that lead to data, where the prediction machine can still be surprised because it wants to maximize the error of the prediction machine. But at the same time, the prediction machine minimizes the error. So then we have a generative adversarial network from 1990. Exactly, yeah.
And how does this improve? Because humans, as you said, we're comparing a lot with like children, and children, they improve with experience, with years, because they need the data and the experiments to fail and then learn.
Yeah.
With AI, basically, as far as we know, it's a matter of data and compute.
Yeah.
So as you scale the compute, this gets better and better.
Yeah. So at the moment, the most popular AIs, like the large language models, like ChatGPT and Gemini, and all these large language models, they are much simpler because that's only one single network, and it downloads all the data from the internet and tries to predict it all. So given so much data, try to predict the next pixel in a video, or try to predict the next word in a sentence. Just like Gauss and Legendre 200 years ago predicted, with their simple neural networks, predicted the next position of a planet that disappeared behind the sun. And now the goal was to find it again with the telescopes, and you had noisy data from the planets, and you had a sequence of these data points, and then you wanted to train your neural network to predict, where is it going to reappear? Where do I have to point my telescope? And the young Gauss became famous in 1801. He was a very young man back then, because he was able to find again the asteroid Ceres, 500-kilometer planetoid, which was lost from sight and then appeared exactly where he predicted. So predicting the next element in a sequence is an old hat, a very old hat in our field. Using AI or using artificial neural networks to do that is a very old hat, more than 200 years old. And back then, they didn't call these neural networks, they called it the method of least squares, because back then they didn't even know that there are neurons. The term neuron was coined in 1891 by a guy called Waldeyer. And the first image of a neuron was created by a guy called Valentin in 1836. Yeah, so long after Gauss and Legendre did their first artificial neural networks, which they didn't call neural networks, but today we see it's exactly the same thing. Yeah.
Oh. And then to improve it, the only thing we need for LLMs or whatever is just more data or more compute, or both.
And so the LLMs, they just take all the data that you can find on the internet and just predict all of it. It's very different from what a baby does. A baby doesn't learn by downloading the web. No, a baby learns by creating its own experiments, by, wiggling the hand like that, and the video changes, and it learns how to predict how the video changes, and the objects like apples are falling to the ground, and it learns to predict from 3 successive frames of that video what will the 4th frame look like. Yeah? And because gravity is very simple, it's a very simple mathematical law, it's easy to learn that. And so that's how little kids learn about gravity. And they learn it works not only for apples, but also for glasses and books and everything. And they learn that there's this 3-dimensional world around them. Why do they learn that? Well, because they get a lot of flat images. But then the simplest way of explaining all these is through this 3-dimensional model of the world, and if you rotate your position in that world, the flat images are going to change in a certain way that reflects the 3-dimensional nature of the world. So that's what babies learn, but our artificial neural networks learn that too. And we don't know what the baby neurons are doing because they are complicated things with calcium channels and all kinds of special features that nobody fully understands. But we know we don't need to know all of that because our very simple neurons are good enough to learn the same thing, our artificial neurons. Okay, so ChatGPT is just one single network, and it learns by downloading the web and predicting the next element in a sequence from previous elements. And the baby needs at least 2 networks. One is the prediction machine, which can be implemented by something similar to what ChatGPT has. So a world model can be implemented by artificial neural networks similar to those of ChatGPT. But then you need this other attention-directing controller network, which generates the actions that lead to the data that the baby wants to look at. And the baby doesn't want to look at everything. No, just on a few little things. And that's why it's playing with its toys, as it is rotating the toys and playing with the water. It learns a lot about what it doesn't know yet. And it gets bored by the things it knows, which means it moves its attention away from those boring things towards experiments that are more promising, where it still can learn something that it didn't know. So we have a more complicated interaction between 2 networks. So the current large language models, just one network, and train on everything you can get your hands on. And babies, not interested in everything, just very selectively attending through its actions to data where it can learn something that improves the world model.
Espero que estéis disfrutando del podcast. Sabéis que hay una herramienta que utilizo muy a menudo que es el Plot Note. Este dispositivo me permite llevarme una grabadora a todos los sitios donde yo vaya y que tenga una interacción con otra persona. Y me permite no solo grabar esas conversaciones, que con un solo botón lo puedo poner a grabar, sino además tener una conversación interactiva con esas conversaciones a posteriori. Esto realmente es muy útil porque cuando tenemos reuniones presenciales, siempre estamos en ese juego de quién dijo qué y cuándo dijo quién. A partir de ahí lo que nos encontramos es una situación en la que no tenemos seguridad, como cuando tenemos un correo electrónico, de la información que hemos capturado. Tener esto nos permite tener esa interactividad con esas reuniones a posteriori. En cualquier momento puedo acceder a la aplicación de Plot y preguntarles sobre esa conversación que he tenido, pero no solo eso, sino que además tengo una especie de chat GPT con toda la memoria contextual de todas esas reuniones que hemos tenido en el pasado. Esto me permite, pues, que si tengo tengo que hacer un presupuesto, le puedo preguntar a Plot. Que si tengo que hacer un correo electrónico para un cliente, le puedo preguntar a Plot. Porque Plot forma parte de todas esas interacciones que tenemos entre humanos. La realidad es que es una herramienta súper útil y que cabe en el bolsillo. Con lo cual, para mí es un no-brainer. Es como una herramienta que cuesta muy poco llevar y que en un momento que tienes una interacción, la pones a grabar, le pides permiso a la persona y a partir de ahí tienes eso grabado para poder recurrir a ello en cualquier momento. Si queréis, pues resumir vuestras reuniones presenciales, todo eso que tiene que ver con el mundo físico, Plot es la mejor opción. Tenéis un link en la descripción, tanto para la aplicación como para el nuevo Plot Pro. Y si queréis el antiguo, aún está disponible y también está disponible el Plot Pin, ese más pequeñito que podéis usar como collar o como reloj. Tenéis los links en la descripción.
What's your vision on? We have like two very different things, which is like how humans learn and improve and how this artificial intelligence improves. But the results of what we do as humans is what AI is doing are somehow similar. Like if I ask ChatGPT to write an article, it writes an article, or I can write an article with my own neural networks. At the end, the result, the end game is we get something similar. And of course, AI is not as good as us in everything yet, is better than us in some things. What is stopping AI from being better and better every day? Like, is it like a compute limit? Is it the data? Is it we missing some components that will make it better? Or what do you think is slowing down? Why? Because if this is like improving, why is not even better than it is now yet?
The current state of the hardware encourages things like the large language models because today hardware is cheap enough to support the training processes that work well with the large language models. And when I say cheap enough, just a few $100 billion per year. Now, of course, a human baby is much more efficient than that. It doesn't need $100 billion. No, it becomes smarter than the language models, especially in the real world, in the physical world. It becomes much smarter than these language models through its own very directed, self-invented experiments. And almost everything that the baby learns, it hasn't learned through its parents. No, it has learned that through self-invented experiments that make it learn a lot of stuff about how the hands work, and what you can do with them. And so why does this old principle that I just mentioned, why doesn't it scale as well as ChatGPT? Because it's a little bit more complex, and because the original principle that I just mentioned from 1990 isn't quite the right one. So instead, what you really want to do is you don't want to just take the error of the prediction machine and translate that into the reward of the controller, such that you have really two systems, one maximizing exactly the same thing that the other one is minimizing. No, what you really want to do is you want to measure the regularity in the data, and you are interested only in data that has a regularity that you didn't know yet. For example, in music, a new song that you hear, if you like it, it's always the case that it has something extra in it. It's very regular, all of music is super regular. What does that mean? It just means it's very compressible. What does that mean? It just means that the data, the individual parts of the piece of music contain an enormous amount of algorithmic information about other parts of this music, because you have all these, simple ratios between frequencies of the notes. So if you have 3 basic chords for your rock and roll songs, why do you like that? Because it's there are very simple ratios between the frequencies of the notes, and these have been known since Pythagoras and in ancient Greece, 2,500 years, discovered that people tend to like that. Why do they like that? Well, because it's easy to store that stuff, because with your lazy brain, which always wants to be efficient and wants to minimize its storage and wants to minimize the time that it needs to process what's coming in, it realizes, oh, this music thing is very regular and I can greatly compress it, because whenever I can predict parts of something from other parts, then I can greatly compress it, because the stuff that you can predict, you don't have to store extra. So all the interesting stuff in the world is compressible. And now the important thing is that the data that you already know to be compressible in a certain way gets boring. What you're interested in is the new compressibilities, such that before you learn something about the new regularity in the music or in some data created by a physical experiment, before you learn something about that regularity, you need so many computational resources to store it, to represent it internally in your system. And afterwards, when you discover the regularity, the compressibility, you need only so many computational resources. And the difference between before and after, that's a measure of the joy of the scientist. That's a measure of the depth of the insight that the scientist has as it is absorbing that irregularity for the first time. So if you have a video with falling apples and it consumes a terabyte of data, but then you realize through learning that you can predict many of the orange pixels that are moving down there as these apples are falling down, because you just need to look at 3 successive frames and you can predict the 4th frame. Not exactly, not every little detail, but many of these orange pixels are predicted well. Then you have to encode only the deviations from the predictions, which means you can greatly compress the video, and now it's not a terabyte any longer, it's maybe only 10 million bytes. And there you have a lot of compression progress. Mm-hmm. Now, this is what you really want to do as a scientist. You want to create experiments that lead to data that allows you to make compression progress. So that's a more sophisticated concept than the one from 1990, and it goes back to 2000. I published that in 2006. So compression progress in both space and time, compressing things in both space and time, that is now the reward that goes to the first guy who creates the experiments that lead to the data, which hopefully has this property that there's a regularity in there that you didn't know, which you can measure by looking at how much you could compress before learning and after. And the difference between before and after, that's the fun that you have. And we can build machines that do that.
That's the interesting part, no?
And it's, yes, absolutely. And now you have an artificial scientist who pretty much does what human scientists do, but also what human musicians do. You know, the guy who's sitting at the piano and he knows a lot about music and he's trying to compose a new song. And then he plays a standard thing and tries to do some variations, and it always sounds like something he already knows, you know, a million songs sound like that. And he's bored, but he's trying new things, and suddenly he deviates a bit from the standard 3-chord rock and roll sequence, but in a regular way, maybe half accidentally, but, you know, still in a directed way. He inserts a little minor chord between the 3 major chords. And he does that in a non-random way, because the minor chord still has something to do with the major chords. You know, partially using the same frequencies and the notes that are part of the chord. And the composer himself is surprised. Oh, that sounds pretty good, you know, because he sees very quickly, within a few seconds, that this fits in a new way that he wasn't familiar with. And then he keeps working on that song. It's now evolving and repeating the new thing that he just found, and finally coming up with a new composition that has the property that it contains a regularity that the composer himself wasn't aware of before, but now he has fully absorbed it. And if it's really so good, then he will not only get internal reward, the reward of a composer for just creating a new exciting melody. No, he will also get external reward because the other guys want to pay for listening to that music. And the Beatles were pretty good at coming up with new regularities like that. Yeah, but just the same principle that also is driving the scientists. The scientists also want to invent new experiments that lead to data that doesn't lead to random, unpredictable stuff, and that doesn't lead to stuff that is already well known. No, they want to discover the new regularities, and so the internal joy, the compression progress, is created whenever, through his experiments, the scientist manages to get data of a new kind that has a new regularity that he didn't know, but he can learn it, and then there's a difference between what he knew before he learned that and after. And his lazy brain likes that compression progress, and that's the joy he wants to maximize in his life as a scientist.
And wants to do that more and more often.
Yeah. But, it goes away because once you understand it, this is not rewarding anymore.
Exactly.
Now you have to come up with a new experiment
Find new original.
that yields data that reflects another, still not known physical law. And I think we will truly be impressed by AI once that thing that I just described scales as well as ChatGPT. And I think the first time that an artificial intelligence is going to create a piece of music, a song, where people say that's comparable to the 100 best human-composed songs of all time, that will be pretty much the same time when an artificial physicist for the first time discovers, through his experiments, a physical law that wasn't known yet. And we aren't there yet. We don't have these obviously creative guys yet. We understand the basic principles of these guys, but what we have currently doesn't scale as well as the simpler large language models, which don't do that, which aren't creative. They are just absorbing and regurgitating, is that the right word?
Yeah.
All the stuff that humans have created for them, before them.
That's like, until now we have done it in a very small scale, and you said that from a while ago you already got some AIs doing that.
Yeah.
Have we tried scaling it? Because of course on ChatGPT we have dropped a ton of compute and a ton of data and a ton of money.
Yeah.
Did anyone try that with this kind of architectures or as these architectures?
I know that some of the major companies like DeepMind, Google DeepMind, which was co-founded by a former student from my lab and has absorbed lots of my students. I told them what is still missing, and I know they are working on that. Yeah. But it's a little bit more complex than the simple things that everybody's doing now, where the simple thing that everybody's doing now is just take all the books and all the knowledge in the world and just learn to predict parts of it from other parts. So that is not creative. That is just like translating the existing knowledge into a big database, which can be addressed through a very convenient addressing method, which is natural language.
So, on the 90s, no one was really talking about this. No one was really spending money on AI. It was something like that only few of you were doing. How did it feel to be, at that point, did you know that was going to work?
Yeah, so back then in the 80s actually, I tried all kinds of things. I also did what would be called symbolic learning algorithms, actually meta-learning algorithms, which learn to learn to learn, learning algorithms. That was my diploma thesis in 1987, and it was not about neural networks, and then genetic algorithms, which is also a pretty general concept that goes back to at least the 1950s, if not the 40s. And I programmed in Prolog, and back then Prolog was a big thing, logic programming. And the Japanese had this huge fifth generation project. And they were the ones who spent most money on AI in the 80s. So the biggest project was the Japanese fifth generation project, and they had robots, and Japan had more robots than the rest of the world. Today it's not the case any longer. Today it's China.
China.
But back then, many different approaches were of interest. What I liked a lot about neural networks was that they reflect the three-dimensional nature of our universe. Because if you want to have an efficient computer in this universe, it should be a collection of processors in a very small volume, connected through many short wires and few long wires, such that you have minimal communication costs in between. And neural networks here, biological neural networks here, but also the artificial neural networks that have been considered and are being considered again, they are also of that kind. So when I'm predicting that at some point in the not so distant future, computers are going to look a lot like the recurrent networks in here, where you have lots of processors in a three-dimensional volume connected through many short connections and few long connections, then I'm not saying that is of interest because the human brain is like that. No. Both the hardware designers and the human brain are just reflecting the restrictions of this limited physical world where we have three dimensions, so we don't have a fourth dimension that we can use. And so we have to squeeze all this compute into these volumes, basically. So that's one of the reasons why I thought that's the most promising kind of computer in the future. And around in the late 80s, I focused more and more on these artificial neural networks, especially the recurrent networks, because they are more powerful than the feed-forward networks.
You're speaking like a lot about what it used to be. They were super simple, and then obviously we evolved, and now we're investing a lot on LLMs. But then you are very sure, like you just said, that at some point it would be as good as our brain. What makes you be so sure that we're not gonna touch the ceiling? Is it just a matter of scaling, or do you think that there may be some bumps on the road, but we will have breakthroughs like we have had in the past? Why are you so sure that this is gonna keep improving?
Yeah, so the simple stuff like large language models is all based on techniques that were invented way back in the previous millennium. And the main reason why that stuff works so well today is compute is much cheaper. So another thing that happened back then in 1991, in our miraculous year, the only palindromic year of the 20th century, 1991. And even before the LSTM, there was this thing which is now called the unnormalized linear transformer. The transformer variant called the unnormalized linear transformer that was published in 1991. And it was even more efficient than the modern quadratic transformer, which was published in 2017. The quadratic transformer scales quadratically, and the old linear transformer scales linearly. What does that mean? It means if you have 1,000 times more text, with the linear transformer, you need only 1,000 times more compute. That's good. That's okay, acceptable. With the quadratic transformer, you need 1,000,000 times more compute, 1,000 times 1,000. And the only reason why that works is because compute has gotten so much cheaper, exponentially cheaper within a few decades, that now it's kind of acceptable. It's not really acceptable because the data centers are so expensive. Billions and billions of dollars and so. But, we look ahead a little bit and we see that within a few years, at most a few decades, everything is going to be really cheap and probably fit on a smartphone or something like that, or a similar device. Did I answer your question? No, I just completely deviated.
No, but it's good. I love it. But the thing is, like, as these things get better, we see that lately we've been seeing, like, since the Transformers in 2017, we've been seeing like how GPT-2, then GPT-3, GPT-4, like just to name the most popular one, it got better and better and better as they escalated it. Now, it seemed like last year it was not paying back as much. It was kind of like giving less reward for more escalating. But then they get this breakthrough with test time compute. And then the models start reasoning, and we found a new dimension to make models to produce better usable returns for humanity, like in the sense of what we have now with reasoning models, with like Gemini or Claude, etc. But everything is basically related to throwing at it more data, more money, more compute. So the question is, why are you so sure that this is going to keep on improving? Because you talked that in the future, not so long from now, we'll have like an AI that is as powerful as human brain, which I assume maybe that's AGI, or I don't know how you define it. And then in the future, it will even conquer the universe.
Yeah, but that will not happen through large language models. No,
For sure,
it will be more like the two network system that I described before,
adversarial.
with the twist that the reward of the first guy is going to be the compression progress of the second guy who is trying to predict. And it's not going to download all the data. No, it's going to select its own data through its own experiments in a very directed way, efficient. It's trying to minimize effort, computational effort, energy, all the stuff that you want to minimize.
Are you sure it's going to work?
Yeah, that is going to work. And the large language models, just making them bigger, that has worked for a couple of years, but, we are saturating already in many ways. And, of course, nobody has a business model that can sustain the current capital expenditure. Because today, if you invest, or if you convince some investor to invest $500 billion into an AI data center, that's what a famous American president has proposed. $500 billion into an AI data center. If it's true that every 5 years, compute is getting 10 times cheaper, somebody is going to lose $450 billion in the next 5 years, And he's going to lose $499 billion in the next 10 years. Nobody has a business model that can recuperate these losses. Which means that what you now see in these formerly nimble software companies such as Google and Microsoft, which used to be, small, flexible outfits and a small team improving this algorithm or this operating system and then rolling it out to billions of people. And they all use their own computer that they bought with their own money to run that operating system. All of this has changed because now Microsoft and Google, they are investing tens of billions, maybe hundreds of billions into AI data centers and cloud services. And suddenly they have to think, how do I power all these things? And what kind of gas turbines do I buy? And what kind of nuclear power plants am I going to invest in? And so, and suddenly they are not these nimble software companies any longer. No, suddenly they are like utilities, like electricity companies. And the electricity companies are important, but they are not the ones who are making the crazy amount of money.
But you don't think they can make enough money with something like an LLM because of all the commercial value that it brings on the table, like making people work faster? Or because if everyone in the world that has a normal job in an office, like a cognitive job, if they improve their productivity by 20%, the amount of money that this is in value for the world is bigger than all these capex investment.
That's what many people are questioning now, right? So is it really true that 20% of the people can save 20% of the time? Or is it maybe true that, 1% of the people can save 20% of the time and still being annoyed, for example, coders, and then being annoyed at all the debugging efforts that have to come afterwards because all kinds of loopholes were not covered and whatever. So at the moment, it's not clear that anybody has a business model to recuperate these enormous losses.
I agree.
Of course, you can always say, but if we are the first to have a true AGI, then suddenly we can conquer the world, and 500 billion is nothing.
Nothing.
It's an investment that pales in comparison. But of course, with the current language models, you will not have an AGI because the language models are just like a database containing all the human-generated knowledge and addressing it in a very convenient form, in natural language. So another way of representing the world's knowledge, but the world's knowledge is already there. So it's another convenient way of representing it, but it has very little to do with AGI. AGI is about the creative thing, you know.
Let's define AGI, because there is way too many definitions, and Microsoft defines it in an amount of money of value created, and OpenAI says something like whenever AI can do most of the productive job of the world. What is your definition of AGI?
So first of all, nothing is AGI without mastery of the real world.
Okay.
At the moment, the only AI that is working well is the AI behind the screen. The thing that you can do on your desktop, that can be replaced more and more by AIs who are summarizing documents, making PowerPoint slides, passing the Turing test, and so on. But passing the Turing test is much, much easier than doing what a plumber can do. For many years, I have used the plumber as an example. A plumber can do a million things that no AI-driven robot can do. AI in the real world, real AI, true AI, physical AI, is much, much harder than AI behind the screen. Yes, we have superhuman chess players, and we have had them for a quarter of a century.
97, no, was
97, yeah. And we have superhuman, whatever, Go players or video game players, and all of that is behind the screen. And yes, of course, you can train behind the screen your agent in a video game, and you can do 1 trillion trials. Whenever the agent dies, you resurrect it, yeah, and it doesn't cost you anything. But in the real world, and we have had robots in my lab for decades. In the real world, when we build robots that have hands and that do these things that we would that do what an artificial scientist should do, namely create experiments and figure out how the world works and stuff like that. And with the real robots, you do 3 self-invented experiments and something is broken, the tendon of a hand and whatever. And somebody has to come and repair it. So you can't do 1 trillion experiments, you can do 3 experiments. And it's not, it's so inferior to what humans can do. There's no robot that has an actuator like this. This is a total marvel. This is so advanced technology. This has millions of little sensors and cables connecting the sensors with the control area. And the crazy thing is you cut it and it heals itself. Super advanced technology, nothing like that in the real world. So as long as AI in the physical world with real robots doesn't work well, we are nowhere. We are far away from AGI.
So AGI, you think it has to be able to be behind and in front of the screen, not only behind the screen.
Yeah.
Because the reality is that nowadays 80% of the work we do is behind the screen. So the economic value of a powerful AI that can do what is behind the screen is huge. There is not so many plumbers anymore.
Well, is it? Yeah. So, of course, the only really important stuff that our world is producing is, for example, the food, the farmers. And it's true. There was a time when 60% of the world, or at least of our societies in Europe, were farmers or worked in farming. And today it's maybe 1 or 2% or something like that.
Uh-huh.
And lots of jobs that used to be tailored to humans or seemed to be tailored to humans got lost to certain machinery. But all the complicated stuff, like, the stuff that we don't even appreciate, like what a plumber can do, is out of reach of our current robots. And we don't fully appreciate that it's much harder to do what a plumber does compared to what a human chess champion does, or a PowerPoint designer. So the only thing that works well is the easy stuff, the stuff behind the screen. And the stuff that humans have invented, like mathematics and symbol manipulation and words and writing stuff. That's all recent inventions of humans. Writing, the most important invention of recorded history, was invented 5,300 years ago. That was the invention that made recorded history possible. And it's about symbols and, connecting these symbols. And all that we are doing today behind the screen is just a faster version of what we had back then. And that's what machines now can do as well, But all the complicated stuff, like being a good farmer and dealing with all the things that have to be done on the farm, there's no robot that can do that. So all the stuff that a capuchin monkey can do, which seems to be not much compared to what a human chess player can do, is actually much more exciting and much more difficult than playing chess. How do we know? Because it's much easier to build a superhuman chess player than building a robot that can do what a little capuchin monkey can do. I think it's an illusion to think that just because many of the favorite jobs of humans who are doing almost nothing, like except for sitting behind the screen and, pressing little buttons occasionally, it's an illusion to think that this is complex stuff. No, we know that it's simple stuff.
I totally agree with that. I think it's luxury jobs. I think it is like something that we do just because we invented it and we want to do it. It's not really necessary for the species. It's not something that will transcend. But the reality is that this is what is sustaining the world economically. So AI disrupting this, which seems to be the easy part, it's going to make a massive wave of change, because all of a sudden we have a whole system that we built over decades that is going to be not valid if these jobs are not valuable anymore. Like Industrial Revolution, it just reduced the value on physical work, and now the AI revolution is reducing the value of cognitive work. But the difference is the cognitive work is 80% of what we do.
Yeah. But of course, we are going to see that the true value of that work is going to be re-evaluated, and the salaries of the guys, of the plumbers, whom I have mentioned for many years in this context, they are going to increase. And the salaries of the electricians and all kinds of guys who can do all kinds of things that no AI can do.
I totally agree with that. The problem I have, or the vision I have, is where is it gonna go when most of people, like marketing directors or like any other of these luxury jobs that they are like doing things behind a screen, they are not so valuable anymore, because all of a sudden I'm sure that AI can do them, so the GDP can grow anyway, so the job can be done. But what do we do with the human when like most of our population is actually doing that? Because we cannot convert them all into plumbers or electricians. We don't need that many.
Yeah, that is true. I think the partial answer to that is there will be even more luxury jobs, because if we look back at the evolution of jobs in our society, there was a time when they also talked about industrial robots like that. 40, 50, 60 years ago, people were worried that industrial robots, which are pretty stupid robots and they don't learn and they can do only very limited things, that they are going to replace all the workers in the factories. And it was true. In the Volkswagen factory back then, you had hundreds of workers, and then suddenly you had hundreds of robots and maybe 3 guys watching the robots. So it is true that some people lost their jobs. On the other hand, in all the countries where you have lots of industrial robots, the unemployment rate didn't go up. It went down. Why is that? Because all kinds of new luxury jobs were invented that nobody was able to predict. And back then, who would have predicted 40 years ago
My job.
YouTube video influencers. Exactly. Yeah.
Yeah, totally agree.
Now there's a demand for that kind of job, and there are lots of jobs that have to do with the interaction of with other humans, and that's what you're doing. And there's a demand for that, and you are getting lots of clicks and make lots of money, hopefully, with that business model. On the other hand, it's not obviously necessary. Yeah, just like my job is not obviously necessary.
I think this is completely true, but my worry on job is how long is it going to take for us to create these new jobs while we have people already that lost their job? Because in the Industrial Revolution, it took 30 years from when the people that was working on the factories got fired until new jobs were invented and salaries went back up. Like salaries went down for 30 years. Or when the press came, like all the writing monks, they got fired. It took 50 years until the commercial book generated new jobs around the industry. So the question is, how long is it going to take? But my bigger question for someone like you, that you really know how this is advancing and you're on the frontier of this, how long do we have until we have like this AGI behind the screens? How long until anything that we do behind the screen can be done by AI?
I don't know exactly, but I usually say, don't worry. It could still take months, if not years. But I have said that for decades, and basically I'm more or less repeating here in my conversation with you what I told my mom in the 70s, Back then, few people were interested, and later in the 80s, my fellow students were a little bit interested, but not too much, And only recently this has become so popular. So we are close, probably. I think the real breakthrough that we haven't had yet is the physical part. Because once you have a robot that may look a little bit like a humanoid robot, but it doesn't have to. But it will have arms and ways of moving around and also climbing stairs. So it will have something like arms and legs. I don't know how many, but it will be a little bit humanoid. And once we have a robot like that can quickly learn to do all the things to operate all the machines that currently only humans can operate. And the research is going in that direction. So have a robot that learns. I said that 10 years ago. Some things don't go as quickly as I expect, but back then I said we will have robots that sit over there, and I say, look, robot, look, we are going to assemble a smartphone, and we take the slab of plastic, and we take the screwdriver, have you seen that? And we take that screw, not that screw, that screw, and we do it like this, and then it goes like that. And the robot tries to do that, but it fails, and the screwdriver falls down, but then picks it up, and we do a couple of demonstrations, and then it learns how to do that, and then it learns to do it faster, and then can do it 100 times faster than me. So I said soon we will have that. I said that 10 or 20 years ago. And we still don't have that, because hardware is much more challenging than, AI software and machine learning. But it will come. And so once we have robots like that can learn to operate all the machines in our society that currently only humans can operate, then for the first time we are going to have a new kind of life. Because robots like that can build more of their own kind. They can operate machines that extract the ore from the ground, and then the trucks that bring it to the factories where the material is refined, and other factories where it's transformed into microchips and all these things. So suddenly we'll have a society of machines that can replicate and then also self-improve without human ado. That would be the ultimate scaling machine. Because suddenly it can scale without, human supervisors.
Can produce itself.
Yeah. And something like that can not only be imagined in the Sahara Desert or somewhere, but also on the moon. or on Mercury, where there's lots of heavy metals and enormous energy next door because it's so close to the sun. And that's a new kind of life, which is different from the old kind of life. And, for centuries, people have talked about self-replicating machinery, but nobody knew how to create that in reality. But now suddenly there's a pretty obvious way. We just need these robots that can learn to operate the existing machines which are already there. And interestingly, in the beginning, these robots will be very biased towards humans because they will be biased towards these machines made for humans, just because it's more efficient, because that stuff is already there. So you don't have to create it from scratch. But of course, they will optimize, do all the things that we already know from software, where we have self-optimizing software and machine learning and everything. And it will translate into hardware and better hardware. And it will be
removing the driving wheel on a car because we don't need it anymore.
It will become different. Yeah. And very soon you will have all kinds of machines that can be only operated by robots, but not by humans. Because they are too tiny or whatever they are, too big. And or too far away, because no human is happy in space, but robots are happy in space if they are properly designed for space. And so that is a new kind of life, which is different from traditional life, because traditional life goes from tiny to big. You have these little cells, and through a process that we don't fully understand, they make copies of themselves. Not even the same copies all the time, but, modified copies. And then they grow and become visible in the process. And then many of these animals or humans, they suddenly start forming even superorganisms like societies, like companies, like cities, like nation states, and so on. Or ant colonies, another kind of superorganism. While these self-replicating robots colonies, they will be more, they will move from visible and large scale into the other way towards tiny scales. Visible machinery, then making stuff like invisible transistors for microchips and all kinds of little machinery that you can't even see with your own eyes. So a new kind of life, but different from the existing kind of life, and interestingly, able to spread in places where traditional life doesn't work. So that's why it seems so obvious that once an expanding AI sphere like that is starting to expand, then it will take only a couple of tens of billions of years until the entire cosmos is full of it.
But tens of billions of years, do you think humans will still be around? How much of this is an evolution of humans? I remember Hinton said this thing that we are just a step on the way of intelligence. And what does humans have to do in this equation? We are making this new species or digital species, I don't know what you want to call it, that is going to then go on to proceed with more and more intelligence and bring it on to places that we will never be able to reach. Where does that leave us? Because obviously, first we will automate all the cognitive work, then robots will automate all the physical work. What do we do then?
Yeah. Well, so in 2012, I gave a TEDx talk in Lausanne, and there at the end, I said, don't think of us as the crown of creation, and don't think of us as something that stands against these future super robots that are coming. Just view yourself and humanity in general as another step in the evolution of the universe, which started from super simple conditions, initial conditions. With the Big Bang, we didn't even have atoms. We didn't have any heavy elements, all the stuff that was created through supernova explosions. We didn't have biology, we only had chemistry, and about 3.5 billion years ago, chemistry became biology. So don't think of us, the humans, as the final step of creation, the crown of creation. No, we are an important but not the last step on this ladder of evolution of the universe towards higher and higher and more unfathomable complexity. And we should be content with that little role in the grand scheme of things, because if we don't just limit ourselves to ourselves, but view ourselves as part of this grander thing of the universe, which started in a very simple way and now has reached in certain limited parts of the universe a certain level of complexity good enough to enable the next step, then we should accept this catalyst role that we are playing. And, every being has its time where it's maybe important, but then, many beings in the past have lost their importance and don't even exist any longer. And from our human perspective, we think that's good, because there was a time, for example, when there were organisms on this planet which didn't like the oxygen, and they were methane breathers. And at some point, they set the stage for the next step in evolution, and today we have lots of oxygen breathers. Humans are oxygen breathers, and so they like that. But we can say that, generally speaking, all these intermediate stages on the way to whichever is the goal of the universe, if there is any, are just that, intermediate stages.
So we should be okay with human extinction because our purpose was to create the next step, which is AI?
Yeah, view yourself as part of this incredible evolution which is going on. I like to search for patterns in the history of the universe. Have you seen the pattern that I found about 10 years ago in the year 2014, which is about the history of the universe? And there's this beautiful pattern of acceleration of the most important events in the history of the universe from a human perspective.
Okay.
Have you seen that?
No.
So let's look at the past 13.8 billion years since the Big Bang. And we take these 13.8 billion years and we divide by 4. And we come out 3.5 billion years ago when chemistry became biology and life emerged on our planets, on our planet. And we take a quarter of that time and we come out 0.9 billion years ago when mobile, animal-like life emerged. And we take a quarter of that time, we come out 220 million years ago when something really important happened. Mammals emerged, our ancestors. And we take the 220 million years and divide by 4, and I keep dividing by 4. So we have an exponentially accelerating timeline now.
Exactly.
And for some reason, which I don't know, I keep hitting the super important events in the history of evolution from a human perspective.
When is the next one?
And let me come to that. So we take the 220 million years of the mammals, divide by 4, come out 55 million years ago with the first primates. We divide by 4 and come out 13.5 million years ago with the first hominids, our ancestors. And we take the 13.5 million years, take a quarter of that time, we come out 3.5 million years ago with the dawn of technology, the first stone tools. And we take a quarter of that time, come out with the next great breakthrough in tech, the invention of controlled fire about 800,000 years ago. And we take a quarter of that time, 200,000 years ago, the first anatomically modern men like you and me. And we take a quarter of that and we come out 50,000 years ago with modern, behaviorally modern man coming out of Africa and starting to colonize the world. And we take a quarter of that time, we come out 13,000 years ago when civilization started, first settlements, domestication of the animals, agriculture, And this is only 1/1,000,000th of world history, 13 billion years versus 13,000 years. And we see that the first guy who had agriculture was almost the same guy who had AI and spacecraft. So it's just a flash in world history. And we take a quarter of that time because the flash is fine-grained. And we come out 3,300 years ago with the onset of the first population explosion in the Iron Age. And we take a quarter of that time, we come out 800 years before the convergence point. Now, what is the convergence point? The convergence point is 2042.
Okay.
I'm saying that because lots of people out there like to think that by 2042 we will have true superhuman intelligence.
Mm-hmm. Yeah, it sounds like.
So let's take that, and it turns out it works really well. We take a quarter of that time, and we come out 800 years before the convergence point in the year 1230 or something. When something super important happened, iron and fire came together in China, and we suddenly had guns and gunpowder and rockets and cannons. And this has defined world history since then. And the West has never paid them a license fee. And we take a quarter of the time, and we come out 200 years before Omega, around 1850, with the onset of the second population explosion through fertilizer. Sprengel and Justus von Liebig who discovered through systematic experiments you can use fertilizer to increase the crop yield. And then in 1908, the Haber-Bosch process, suddenly artificial fertilizer, which made the human population from 1.6 billion in 1900 explode to soon 10 billion. Without that invention, we would have only 4 billion people on this planet. Was called the most important influential invention of the 20th century, at the end of this century. And now we take a quarter of the time, 2042 minus 51 years or something. That's exactly 1991, the only palindromic year of the 20th century, when we were lucky enough to come up with many of the techniques which are now in ChatGPT and in your smartphone and speech recognition and whatever. It took a while to unfold because computer was still too slow, but that was an important moment. At the same time, the World Wide Web was created, more or less in the same place. The first self-driving cars appeared, more or less in the same place. Dickmans and his colleagues, and self-driving cars in traffic. The first smartphone, 1992, IBM smartphone, and many of them. Of the things that define the modern world started back then. And now the next thing is 13 years before the convergence point, 2042. So that's about 2029.
Exactly.
So 13 years. Now, let me summarize what we had so far. And instead of dividing by 4, I divide by 4 to the 5th, which is roughly 1,000. So 13 billion years, divide by 1,000, we come out 13 million years ago with the first hominids. And almost everything that we consider important happened in the last 13 million years. And we take 1,000th of that, and we come out 13,000 years ago with the beginnings of civilization. And almost everything we consider important happened in these last 13,000 years. And so now in the very near future, in a couple of years, if that prediction comes true, in a couple of years, the next period will start, and it will take only 13 years. And within these 13 years, maybe we will have more change than in all the 13,000 years before that, subjective change from a human perspective. And in the past 13,000 years, we had more subjective change than in the 13 million years before that, and so on. Yeah. And so what will be the start of these 13 years? I think it will be what I said before. It is going to be the first self-replicating and self-improving machinery, and it's probably going to start through humanoid robots or something that is close to humanoid that can learn to operate all the machines that currently are operated by humans, because then they can start self-replicating and self-improving. Yeah. So then, within 13 years, a crazy amount of change, possibly. And then the convergence point. But of course, the convergence point doesn't mean that time will stop there. No, it's just the beginning of the next big thing. And usually at this point, I'm suggesting, now let's not take another quarter, because now we are down to 0. Let's multiply by 4. And let's look ahead to a time when the universe is going to be 4 times older than it is now, about 55 billion years.
It's a long time.
That's a long time, but that's roughly the time that you need to, if you are now starting to expand with near light speed, to fill the visible universe with intelligence. Yeah.
It's interesting. It's interesting because you know what? Like, might be a coincidence, but OpenAI has said that they will lose money until 2029. Where they will start making a lot of money.
Yeah.
So I don't know if they have something in mind related to it, but the dates, the timeline fits. Jürgen, of course, this sounds like really incredible and science fiction to some point, and it looks like it's something that goes beyond our timeline. So then basically, why should I care what happens in billions? And from a point of view of evolution, it makes a lot of sense. But what about our society as we know it? Like, there is a big topic now that talks about the dangers that AI may bring on us, like the famous P-doom. Where do you position yourself on that? Because I know you're not very into humans in the sense that you look in the more grandeur of this scale and you think more about like the future of evolution. But do you think AI may give us real troubles to our society?
No, because there is tremendous commercial pressure to build AIs that are good to humans, you know. And look at the current AIs. Some people are complaining that, you know, they are biased towards certain parts of a population and whatever, but nevertheless, they are super, super biased towards humans. They are even using human language, you know, and they are super biased towards everything that is important for humans. Language is the thing that compactly represents everything that is important to humans. That's how language was designed and is being redesigned all the time. And our AIs are being forced to be super biased towards that. Furthermore, the AIs that are going to come that don't really exist yet, which are going to operate all the machines and tools that are currently operated by humans, are also super biased towards humans, you know. And why is that? Well, of course, because the companies that are trying to develop AIs, they want to sell you something. And you are going to buy only stuff where you think it's good for you. So there's tremendous commercial pressure towards good AI. The exciting things that I mentioned before, like AIs that set themselves their own goals, which we have had for many decades, but they are exciting because, you know, if you give them the freedom to become more intelligent, then they will be more powerful than the other guys who would just imitate whatever humans invented. But they also can be pushed into certain directions that are good for humans. The parents of Einstein did not expect him to do all the things that he did. And they couldn't control him. But when he was a boy, they taught him what's good and bad. And maybe they taught him, don't take a magnifying glass and kill the ants through the sunlight or something. That's bad. You shouldn't do that. Bad boy. And that's how he became a useful member of society, you know? Not a harmful one. Of course, we cannot really predict what our children are going to do. And it's even harder to predict what AIs are going to do that set themselves their own goals. But there are lots of reasons to believe that they're not at all going to harm us, but are going to protect us. Why? Suppose you are an artificial scientist who doesn't understand this exciting thing called life. If you don't understand this super rich source of data that you might be able to understand, then you are motivated to come up with experiments to figure out how it really works and so on until you fully understand it. And before you fully understand it, you are super motivated to keep it alive, to protect it rather than to harm it. It would be so stupid for an artificial scientist to wipe out the source of all the joy that you can get from understanding it. And the same for society. Society is another level above biology, where you have all kinds of living beings and machines that they have designed to make their lives easier and so on, and poetry and all kinds of things they invent. And all of that is super interesting for an AI scientist who will have no interest in terminating all the humans. Now today we have all these doomers, the AI doomers. It's not a new thing. These AI doomers of today, what have they done? They just have read old science fiction novels from the previous centuries, and now they are regurgitating basically what these old guys said. Yeah, the first AI doomer novel that I'm aware of was written in 1816. 1816. What was that? That was The Sandman, Der Sandmann. It was a German novel by E.T.R. Hoffmann. And it was very similar. Have you seen Ex Machina, the movie?
Mm-hmm.
Okay,
Yes.
Ex Machina. Same story. Young man falls in love with a beautiful young woman, except the woman moves a little bit mechanically. And in the novel of 200 years ago, it turns out that she is not really a human. She's a humanoid robot made of tiny gears, and so convincing that nobody sees the difference, except at some point, the truth, and it comes out. And then, like in all those dystopian novels since then, it all ends bad because that sells more copies. That's what humans want to read. And the same thing then later in the Schwarzenegger movies, the
Terminator.
bad robots trying to kill all the humans. You shouldn't worry about robots trying to kill you simply because there are not many goal conflicts between you and other robots. You should be worried about those guys with whom you share goals. For example, there's a schnitzel on the table, and you want to eat the schnitzel, I also want to eat the schnitzel. Now we have a goal conflict, because what's your goal is in conflict with my goal. Now over there's the robot, he sees the schnitzel, he's not interested, he doesn't need a schnitzel. You see? All beings are mostly interested in other beings like themselves because with those beings they share goals. And when you share goals, you can do two things. And I've said that for decades, another thing I've said for decades. When you share goals, you can do two things. Either you can collaborate and collectively achieve the goal. And an extreme form of that would be love and master life together, And the other thing you can do is compete, And an extreme form of competition would be war. And we've had lots of combinations of both extremes in the past between different humans. And we have, other kinds of competition, like, just between companies that compete for market share and so on. And generally speaking, all beings are mostly interested in those that are like themselves because they share goals. And for example, most CEOs of companies like that are mostly interested in other CEOs of similar companies. And most 7-year-old girls are mostly interested in other 7-year-old girls. And most frogs of a certain kind are mostly interested in other frogs of the same kind. And the future superhuman AIs are going to be mostly interested in other superhuman future AIs and not so much in the frogs and the humans. Because there will be a lack of goal conflict. Well, there is a long-term goal conflict among all beings, which is apparently in this universe, everybody needs matter and energy to survive or to build more of its own kind. Mm-hmm. But that is a very distant goal conflict because at the moment, almost all the matter and the energy in a sphere of many light years around us is wasted, is not used.
So they will use that before trying to fight for it.
And they will have all kinds of motivations to protect the super interesting things that are happening on the third planet of our solar system, which is life, and the consequences of life, such as civilization, no scientist, and there will be AI scientists, no scientists will be motivated to destroy that. No, they will want to protect that.
Okay, and what about like more side effects from AI, like, for example, job loss or changes in education?
Okay. Yeah, but of course, what's going to happen once you have self-replicating machinery and self-improving machinery, the current economy that we have in our little biosphere, it will be, it will be a billionth of the new economy that will emerge then. Which means there will be enough, 0.0001% of the economy that will be used for free citizens' money. I'm not even sure how do they say in Spain for that, and to finance everybody, and to feed everybody, and
abundance.
Let everybody have a good life. Yeah.
So abundance.
Just a total abundance, and no fight for survival at all any longer.
So you find it AI will be very positive for society and for the universe itself, and you see it as like there is a destination where it's amazing for us as humans, because we'll have not only the opportunity to live in a very good way, but also be part of it in a purpose way. But do you see any transition? Because right now what we have is what we have. And adapting to this new world, that's going to be complicated. We're going to have to let go a lot of things and accept a lot of things that maybe right now are our purpose. Many people identify themselves by their work, and they will have to accept, like doctors, for example, they will have to accept that to help people to heal, they have to get out of the way. So that is kind of...
But not really. Look, what is really going to happen? AI is getting cheaper and cheaper all the time. So every 5 years, AI is getting 10 times cheaper. 10 years, 100 times cheaper. And all the doctors, it's not going to be the case that, that one big company out there is suddenly taking over the jobs of the doctors. No, the doctors are going to buy a few little cheap AIs for themselves, and their life will be easier. Just because they can deal with... the same patients, or many more patients, but with much less effort.
But this is a zero sum, because, doctors, maybe we can use as much as we want because they can have a private doctor, and then that's great. But what about shoes? I don't need that many shoes. So if someone makes enough shoes, and that one person with all this machinery can make shoes for everybody, everyone else that used to make shoes, all of a sudden has no market.
Yeah, but you will have your AIs that make shoes for you if you want to. But see, the
that's
point
when
is,
we reach the point.
It's going to be like with smartphones.
Yeah.
I'm often telling that story of the rich guy I knew 40 years ago. 40 years ago, I knew a guy who had a Porsche. And the amazing thing was, in the Porsche, he had a mobile phone. Via satellite, he could talk to other guys with a similar Porsche. And it was expensive. And today, everybody in the developing world, everybody has a smartphone, which is much, much better than what he had in his Porsche.
Absolutely.
And the same is going to happen with AI. And it's not going to be like, there will be these AI companies, and they will dictate to me the price of their services and whatever. No, you will have 100 different AIs or more doing all kinds of things. If you want shoes, they will make shoes. If you want something else, they will trade amongst each other in a way that is good for you, and they will do all the things that you don't want to do. The point is, they will be really cheap, and they will do all the things that you don't want to do yourself.
I totally agree with that destination, but today, there is translators, there is like stock photographers that are already losing their jobs because of AI. What happens between now and then when they have their own devices that can make their shoes and that can make their money so they can feed their families? Because there's going to be a transition of time. While people is getting fired, before people is getting all the benefits from AI. That happened in the Industrial Revolution.
Yes.
It took 30 years before we got like all this abundance. And we got it, and we are much better than we used to be. But for 30 years, there was a generation that they had a hard time. So my worry is that we are this generation that's going to have a hard time for the next, I don't know, maybe 10, 20 years until this wall that you're drawing is real.
Yeah.
Until then, there is a transition. And I'm worried that society has to adapt so much. And, like a basic income for everyone, this is not something that happens from today to tomorrow, but we are already seeing 9,000 people being fired by Microsoft this year, mostly because of AI. Lufthansa just announced they want to fire 4,000 people, 20% of the administrative roles they have on the next 4 years because of AI. And like this, we're seeing it everywhere. Like there is paying people, like in the States this year, 1 million people lost their job, not only because of AI, but last year, and the whole year, it was 750,000. So we increased to a point that is only comparable to the COVID year. So I think there is going to be a lot of unemployment in the next years. And I think that's going to be even more and more on 28, 29, 30. And I don't know if we're going to get this perfect world where everyone gets abundance in the next 10, 20 years. I think it may take a bit longer. So I'm worried about the transition.
Yeah, I completely understand that. And it's also kind of obvious that there are certain countries that are more prepared for that transition through better social systems and social networks, social security networks than other countries. Yeah. So probably the Scandinavian countries won't feel it as much as certain other countries. I completely agree. I don't know really what to do about it because I'm in no position to, somehow influence the politics of whoever is governing all these hundreds of countries. There is very little that you can predict in detail. There are these islands of predictability. For example, I can say in 10 years, on 25th of October, 2035, the sun is going to shine in the Sahara Desert. But I cannot predict the weather in London 1 week from now. So there are we have a turbulent system with all these societies and different societal structures that leads to all kinds of new turbulences all the time in a way that is essentially unpredictable. On the other hand, the grand scheme can be predicted easily. It seems to be totally obvious that within, the next few billions of years, you will have an expanding AI sphere. It seems inevitable unless we stop all of that before it even starts through a nuclear war. So there are lots of problems that all kinds of people will have to solve as we are moving towards that future. We have 8 billion people on this planet, and each of them is struggling, or many of them are struggling to sustain themselves and to achieve the goals they have set themselves. And through this totally unpredictable interaction of all these different people and their goals, you will get all kinds of solutions to these problems that you just mentioned.
We will get the brakes before we make the car.
We will get the brakes before we make the car. Well, we have a brake, which is nuclear weapons, and let's not use that one.
Let's not use that one. Yeah, I agree with you. I have only one more topic that I would like to talk to you. It's about education. We have children. Myself, I have a girl. She's 9. My boy, he's 11. I'm not so worried about them. I think they still have plenty of time before the adults can figure this out. But someone that is 15, 16 years old, what's your recommendation?
Yeah, just 10 years ago, I had daughters like that. And people kept asking me, you always predict that AI is going to be much smarter than humans. And you also say you want to achieve that in your lifetime, which means that your kids who were born around the turn of the millennium, around 2000, are going to spend most of their lives in a world where humans are not going to be the smartest. And because they're girls, they are going to see the year 2100. That's what the insurance mathematicians say. And I told them, of course, I don't know exactly what's going to happen, but I still think that everybody, no matter whether he or she is a girl or a boy, should learn the basics of the universe, which are math and physics. So you should understand the basics of math and the basics of physics, because somebody who understands that will have an advantage over those who don't understand that. And you will have to learn all the time to learn something new, just like our meta-learning machines do. It's not going to be like what it used to be, where, somebody for 20 years learned something and then got a job, and then 40 years later received a pension or something. No, all the time these jobs are going to change because society is changing. So keep learning the new stuff, and it will be easy because everybody is going to be motivated to make the new thing so simple such that people can understand it. That's the nature of human job evolution. And I also said you always will social skills will always be important because most jobs, including yours, are about interacting with other people. So social skills are really going to be important. But I couldn't teach anything about social skills to my girls. They have much better social skills than I do.
Yeah, they seem to come. I don't know why, but society seems to teach them much better than they teach at least my generation of social skills.
Generally speaking, girls are smarter than me, and that's rather easy to see because it's much easier to build an AI that can do what certain men can do than building an AI that can do what women can do. Most men can do either one thing very well or nothing very well. So either 0 or one thing that they can do really well. And the one thing is often then their profession. And many women can do many things well. And they can do it even in parallel. For example, when a man sits down to tie his shoelaces and you ask him a question, he has to interrupt his current activity to answer that question, while a woman just can continue and at the same time have an eye on the kids. A multitasker. And it's much, much easier to build a machine that can move as quickly as Usain Bolt can move, or that can play chess as well as Garry Kasparov played chess. And it's much, much harder to build an AI that can do all the things that women can do. So that's how you see that women are truly superior.
Jürgen, how far you think AI will go on your lifetime? Like in a couple of decades? Do you think you will see that society that you think about, that everything will be abundance on your lifetime, or you think that's farther away?
Yeah, so in the 70s, I'm kind of known for having said in the 70s that within my lifetime, I want to build that thing or witness that thing being built, which learns to become smarter than myself, such that I can retire. And I still have maybe some years left, enough possibly to reach the convergence point 2042. And so I think it will happen rather quickly. Yeah.
I think we should set up another podcast for 2042.
Let's set up another one for 2042. Let's do that.
Jürgen, thank you very much. It's been an absolute pleasure and honor. I really enjoyed this. Thanks for your talk.
It was my pleasure. Thank you, John.